Hey, welcome to Number Buddy. My name is Buddy. Today we're going to be talking about trigonometry. We're going to be talking about the basics of trigonometry. So what I mean by that is both things you may want to know before starting a trigonometry class, as well as some of the very first ideas and concepts that you'll start to learn in trigonometry class. If you start to watch this video and it feels too easy, feels like a review, excellent. Move on to the next video where we're going to talk about what to do instead of the unit circle. If you feel this information is a little bit too difficult and you think I'm moving too quickly and glossing over some ideas or taking some ideas for granted that you don't think you know yet, let me know. Drop a comment and I'll make a video that reviews some of the geometry ideas that we're using here today. But without further ado, let's get into it. So one of the first things that's going to be helpful to understand is that one revolution around the XY plane, or one revolution in 2D Euclidean space, whatever we want to call it, has 360 degrees. We're only going to worry about degrees for right now. We'll get into radians at a later date. What that means is we're always going to be calculating angles as angles starting from the positive x-axis. Okay, so from the x-axis, we sweep through angles, and whatever we land on, that's the angle that we're going to be talking about. So we start with 90 degrees in the first quadrant. And then we go another 90 degrees to get to the second quadrant, or through the second quadrant rather. 90 degrees here, and another 90 degrees here. Okay? So let's go ahead and label each of these here. This is going to be 90 degrees. This is going to be 180 degrees. This is going to be 270 degrees. And then this x-axis here, this positive x-axis, is 0 degrees or 360 degrees. They both lie on the same place. For instance, if we're counting from the x-axis and we go up 0 degrees from there, then we haven't moved at all, which means we're still on the x-axis. If we go from this x-axis and go the entire way around the xy plane, we land back on that axis. We've gone 360 degrees, but we're right back where we started. So 0 degrees and 360 degrees are the same angle. Hopefully, if you're taking a trigonometry class, you've seen that already. Whether it made sense to you or not is a different story, but this is the place to learn it, and this is the place to get a better understanding of that. So, like I said, whenever we're dealing with angles, we're going to be going from this positive x-axis and sweeping up to wherever we end, whatever direction we're landing on, is the angle we're talking about. So for instance, in this drawing I've done here, we've done something like 30 degrees. What we mean when we start to talk about trigonometry, the key to trigonometry is we're going to be talking about right triangles. So you may remember from geometry, you may not. A right angle is 90 degrees, and a right triangle is a triangle in which one of the angles is 90 degrees. So we use this mark here to denote 90 degrees, okay? Now up here I'm kind of drawing just like in floating space. This isn't part of the XY grid. I'm not trying to plot this on the XY grid. I'm just reviewing what a right triangle is here. So one of the nice things about a right triangle is we may remember that all triangles have to have a total angle sum of 180 degrees. Now all that means is that if you take this angle plus this 90 degree angle plus this other angle here, we're going to call this alpha for angle 1 plus alpha angle 2 plus alpha angle 3 has to equal 180. Don't worry that I just called that alpha. That's not super important. All that means for this situation here is if we have a 90 degree angle as one of our angles in a right triangle, the other two have to add up to 90 because 90 plus 90 is 180. So let's say, for example, we have 30 degrees here. Well, we know this other angle has to be something that makes these two add up to 90. And then these two being 90 added to our other 90 degree angle there, we get a total of 180. Let's talk about how we just make any random angle into a right triangle. Because I've drawn you this angle here. at 30 degrees, but it doesn't really mean anything yet. So what we do is whenever we take an angle, whatever direction we land on when we talk about that angle, we're going to take the end of that angle and draw the fastest vertical line to the x-axis. In other words, we're going to draw a line straight down or straight up from the end of that angle straight to the x-axis. When we do that, that always creates a right angle there. It may be in a different position for other angles. For right now, we're talking about this one here. Now we've formed a right triangle where its bottom side is this here, which is this. Its vertical side looks like this. And then this side here, we call a hypotenuse. There's a few different things that we can use to describe the relationship between these sides. The first one is the Pythagorean Theorem. So let's say we call this bottom side A. We would call this vertical side B and the long side C. The hypotenuse always has to be across from the 90-degree angle, and it's always going to be the longest side in your triangle. There's no way to have a hypotenuse that's across from a 90-degree angle that's not the longest side in a triangle, okay? We'll get to kind of special examples where a triangle collapses on itself on the x-axis or on the y-axis, but we'll talk about that later. So, the hypotenuse across from the 90-degree angle, and there's a relationship between these sides, which we call a squared plus b squared equals c squared. You may have heard that before. You may have heard that in a connotation of, I don't understand that and I don't want to learn that. And when you hear the Pythagorean Theorem or even the name or a squared plus b squared, your brain may like shut off. You may just zone it out because who cares, right? But it's not something that is too difficult for you to understand. All we're saying with the Pythagorean Theorem is that if there's a right angle in a triangle, that if you take this bottom side and square it, add this side and square it, it always has to be equal to if you take the hypotenuse side alone and square that, okay? So this is the Pythagorean Theorem. Don't let the name theorem intimidate you. You can work with it. We can work with it. It's helpful to call the sides of a triangle A, B, and C if this triangle was just floating in space. The reason why we want this on the XY grid is because now we can say, oh, A, the length of this side A also corresponds to the length from 0 on the x-axis to whatever x coordinate this is here. So another way you may see A represented is that we may call A x. Okay? Now that's a similar idea over here to this vertical side. This vertical side is this height that this side here reaches to. Or in other words, it's a y value. How far from the 0 of y are we when we're at the top of this thing? So we may call this y. Okay? Well, that means we have x squared plus a y squared equals c squared. You may even see this called z squared. All it refers to is that it's the third side, the long side of your hypotenuse. We have an understanding of angles. We have an understanding of if this is 30 degrees, this side has to be 60 degrees. And we understand how we're going to label the sides of a triangle. What if we are somewhere beyond this 0 to 90 range, right? This is all understandable when we're between 0 and 90, or in other words, in this first quadrant, right? Angles 0 degrees to 90 degrees are going to be in quadrant 1. But if we sweep through, let's say we want something like, we want to plot 120 degrees. What does it mean to have a 120 degree angle? Or in other words, you may see this called theta. Theta is just a letter that we use to represent angles. So let's say we want to find something like where 120 degrees is, and we want to draw a right triangle that represents that 120 degree angle. Well, we just learned that we're going to start on the positive x-axis, and we're going to sweep as far as we need to go. Okay? When we make it to the y-axis, we've already swept 90 degrees. We've swept 90 degrees, and we have to keep going 30 degrees more. When we sweep 30 degrees more, 90 plus 30 gives us 120. Okay, so this entire angle is 120 degrees. Very nice. Now, if you're following along closely, you might look at this and say, okay, cool. How are we going to make a right triangle out of an angle of 120 degrees? Because I told you that all the angles in a triangle have to add up to 180. Okay, if we have 120 and we also want a right angle, which is 90 degrees, already those two angles, 120 plus 90, is 210, which is more than 180. So how are we going to make a right triangle out of this? What is trigonometry doing? So here's what we're going to do instead. The other thing I told you is that whenever you draw your angle, whatever like direction that angle terminates on, you're going to draw a line there. And then from the end of that line, you're going to draw straight down to the x-axis. As fast as you can, get back to the x-axis. And when we do that, we form a right angle there. So really what we've done is we formed a right triangle. We've made a right triangle like this. So you may be saying, okay, cool, we made that right triangle, but that doesn't really represent the 120 degrees because the 120 degrees is on the other side of that right triangle. I hear you, that what you're saying is valid and it makes sense, but we'll see later that it's helpful to actually talk about a 120 degree angle by actually referring to this angle here. So this we're going to call a reference angle. Okay? And the way we're going to find out a reference angle, if this is 120 to get to there, right? We know every quadrant of an XY plane has 90 degrees. Therefore, over here, this is 180 degrees, right? Well, if we've gone 120 degrees from over here, from this blue positive x-axis, how many degrees short are we of getting to 180? And that answer is 60 degrees. Okay, so we drew this line down, formed a right angle there. This reference angle is 60 degrees, and that's the angle we're going to be working with. If this reference angle is 60 degrees, we know this angle and this angle have to add up to 90. So there's going to be 30 degrees. We've drawn a triangle, but this triangle is actually facing the second quadrant, which means our sides of our triangle can sometimes be a little bit tricky. So let's say this length of this side, we would normally call this A equals 5. Let's say, for example, this has a length of 5, right? That's perfectly fine. That's perfectly helpful. But when we describe it on the XY plane, we're actually going to call this x equals -5. You may be thinking, okay, why would we do that? It doesn't really make sense for a triangle to have a negative side length. what does a negative length even mean, right? It doesn't really mean anything. But we're not necessarily saying that it's a negative side length. What we're saying is from where the triangle starts and where the angle goes, its horizontal side, we're saying where does that side end up? If it starts at 0, where does it end up? And it ends up at the coordinate -5. So we're going to call this side x equals -5. Okay? This height is our y value, right? Because we can imagine that going there, and that's a y value. So this y value, I've given you a special right triangle, and we'll learn more about those later. This side would have a certain length, and then this side here, we could use our newly discovered Pythagorean theorem to say, okay, if we know that a squared plus b squared equals c squared, and in the long run, it doesn't really matter which side you're calling A and which side you're calling B. So far, it may seem like I'm sticking with the notation that A is your horizontal side and B is your vertical side. It doesn't necessarily have to be that. You can call your vertical side A and your horizontal side B as long as you're calling the hypotenuse side C. But we have this relationship A squared plus B squared equals C squared. Let's see what that means when we have X coordinates and Y coordinates. Okay? We have X squared plus Y squared equals, let's go ahead and call this Z squared for the sake of getting you used to that too. Well, X is -5. So remember, whenever we plug something in, we're going to plug it in with parentheses. So -5 squared plus 5 root 3 squared, and I gave you that value. That this vertical side is 5 root 3, I'm not expecting you to understand that already. We're going to talk about that later in future episodes. But this 5 root 3 squared has to equal z squared. So we'd say, okay, cool. -5 squared, well, negative times a negative is going to give us positive. So positive 25 plus 5 squared here. Remember when we do 5 root 3, it's like saying 5 squared times root 3 squared. So we're going to have 25 times 3. Squaring a square root just gives you the thing inside, right? And this has to equal z squared. Okay? We have 25 plus 75 equals z squared. And then we have 100 equals z squared. Take the square root, and z equals positive -10. Even though you may have been taught when you take the square root, you always have the positive and the negative option. That's 100% true. But when we're talking about a hypotenuse is always positive. So we're going to take the positive value and call that length 10. All right, I hope you enjoyed today's lesson. If it was easy for you, cool. If it was too hard for you, let me know. We'll make a new video. Next time, we're going to be talking about what to do instead of memorizing the unit circle. So stick around, feel free to subscribe, and I'll see you next time.